In this lesson, we're going to use primary trig ratios to solve real-world problems. So there's two different types of word problems we're going to look at. Angle of elevation, and this refers to an angle that is made between a horizontal line that is drawn and the line of sight up to an object. So let's take a look at an example of what this is going to look like. So from a point that is 15 meters from the base of a building, so here we have our building, and from a point that's 15 meters away, Leah measures the angle of elevation up to the top of the building to be 46 degrees. So if this is our building over here, this is 15 meters away at the base, and then from here up is the 46 degrees up to the top of the building. So there we have our right angle triangle, and the question is, how high is the building? So there's our x. What is the height of the building? So if this is my reference angle, I want to solve for x, and x is opposite from my reference angle, and the 15 meters is adjacent to. So if we refresh our memories using SOHCAHTOA, we have O and A, which use the tangent primary trig ratio. So the tan of our angle is equal to opposite over adjacent. Our angle is 46 degrees. The opposite is x, and 15 is the adjacent. So recall here that we want to isolate for x, so we need to move the 15 over. The opposite of dividing by 15 is to multiply by 15. So 15 times the tan of 46 degrees is equal to x, and if we plug that into our calculator, 15.5, so we're rounding to the nearest tenth, is the height of the building. So therefore, the height of the building is 15.5 meters. So the next type of question we're going to look at, these are called angles of depression, and this is where we have an angle between a horizontal line and a line of sight down to an object. So in this question, we have an airplane over here. It's going to land at Pearson International Airport on the ground over here. The angle of depression that is created is 22 degrees. So from a line, a horizontal line straight out, the angle of depression, so down, is 22 degrees, and that is a line then to the ground here. I'll just change that a little bit. So then this is going to make a 90-degree angle over here. So we know that the horizontal distance from here to here was 350 meters, so that is this part of our triangle. And we want to know how high the plane is. Now the plane is over here, so the height is over there, but that is the same as this part of our triangle. So that is what we are trying to solve. So we have our reference angle over here, and the height is the opposite from that reference angle, and the 350 is the adjacent. So once again, we are going to use the tan trig ratio, so opposite over adjacent. Our angle is 22 degrees that we're using, so tan 22 degrees is equal to h over 350. I need to move the 350. The opposite of dividing is to multiply. by 350, so times the tan of 22 degrees. And when we input this into our calculator, 350 times tan 22 is equal to 141.4 meters. So therefore, the plane is 141.4 meters high.